Hey students, welcome to Code Pathshala. Today we will be solving another interesting problem on LeetCode called the unique paths. Let's look at the problem statement first. So the problem statement says there is a robot on a M by N grid. The robot is initially located at the top left corner. The robot tries to move to the bottom right corner. The robot can only move either down or right. Okay, we have to given such matrix size, we have to print the number of possible unique paths. So if you look at this example, this is the grid that is given. Robo is starting at 0, 0 and it has to go here. We have to find the number of possible paths. Robo can go either right or down. Okay. Robo can go either right or down. So given m equal to 3, n equal to 7, the number of possible paths is 28. Possible paths instance, this is one path, this is one path. Like this, there are 28 paths. Now, for a smaller size of m equal to 3 and n equal to 2, that means only this much. It is only 3 paths 1, 2, and 3. Okay, so let's look at how we can solve this through an example. Okay, so let's say we have a 3 by 3 grid like this. Okay, so the robo is starting here and it has to go here. Okay, it can go either right or down. So how do we solve this? Let's say we have a function m comma n which in this case will be 2 by 2 because uh, these are the indices of it. So what will be the possible paths at 2 comma 2? It would be sum of possible paths here, which is 2 comma 1, and sum of possible paths here, which is 1 comma 2. So if you sum the total number of ways you can reach the left point and the total number of ways you can reach the top point, you will get the total number of ways for this node. Okay, that is because the robo can only go right and down, which is why you are looking for top and left. So this f of 2 by 2 will become f of 2 comma 1 or f of 1 comma 2. Okay, if you sum these two, we will get to that. So let's try to see this. This would be f of 2 comma 0 or f of 1 comma 1. So the f of 2 comma 0 would be f of 1 comma 0 or f of 2 comma minus 1. Okay. Now f of 1 comma 0 would be either f of 0 0 or f of 1 comma minus 1. Now from minus 1 you are outside the array, so there are 0 possible ways. 0 0 is the starting point, so this would be 1. Okay, sum of these two 1 0, for f of 1 0 it would be 1. Here again this is minus 1, so this would be 0. So 1 plus 0 would be 1 here again. Okay, now let's compute f of 1. F of 1 1 comma 1 would be f of 1 comma 0 or f of 0 comma 1. Now f of 1 comma 0 we already computed it here. Okay, instead of trying the recursion again, let's reuse this. So this answer would be 1. So what is 0 comma 1? 0 comma 1 would be again f of minus 1 comma 1 or f of 0 comma 0. So this is 0, this is 1. So sum of these two is 1. 1 plus 1 is 2. 2 plus 1 is 3. Okay. Now if you follow the similar structure on the right side, you will get another 3 here, and 3 plus 3, the output would be 6 at this point. So what we are doing is, we know that f of 0 0 is 1. Anything outside the bounds is 0. So we are recursively computing it, which is basically you are starting at, okay, you are starting at 0 0, then computing 0 1, then computing 0 2, then this cell, and so on. For every cell, we will keep computing until we reach the end. Okay. So instead of recursion, we can do the same in a dynamic programming way using the tabular approach. Let's say this is a DP array. Okay. Let's say we have a DP array of same size. Okay. At every point, we will add the number of ways in which we can reach there. Okay. 0, 0, we know it is 1. So now if you observe for rest of the zeros, for example 2, 0 or 0, 1, they will always be 1. Okay. That is because here from 0, 1, there is no top element here, right? So you will only get whatever is here. Here also there is no top. So you will only get whatever is here. In this case, there is no left. So these things can be filled by default, or you can follow the similar approach of if it goes negative, then it is 0. But since it is anyway 1 always, you can initialize it like this. Okay. Now once you have this, what is 1 comma 1? 1 comma 1 is sum of 0 comma 1 and 1 comma 0. Okay. This one is sum of 0, 2 and 1, 1. So this would be 3. This is anyway 1. This one would be sum of 2 plus 1, 3. Now this one would be 3 plus 3, 4. So our answer would be this one. Oh, sorry, 3 plus 3, 6. Our answer would be 6. Okay. So that is how this recursive function boils down to a simple DP tabular solution. Okay. Hope you understood the simple logic behind this. Okay. So now let's try to write code for it. The code here is also pretty straightforward. The idea is most important here. Okay. Let's say, so we will be taking a DP array of exactly same size of the given matrix, which is M and N. Okay. Now we have to fill the array. I equal to 0, I less than M, I plus plus. Okay. For int j equal to 0, j less than N, j plus plus. What we are doing is what we said. Either you can do if it goes less than 0, then it is 0, or you can say if either I is 0 or sorry, not int, if I is 0 or if j is 0, which means if it is the first row or first column, the number of ways is always 1. Okay, we can initialize that right away. dp of I of j is equal to 1. Okay. In rest of the cases, we will have a previous value already and we will update with that. You don't have to check for boundary conditions and all. We are already looping within the boundary and we computed the previous value. So here when we are going, how we will traverse is we go from 0, 0, then we go like this. So since this is all ones, we will already have the previous values required. Okay. So we can just directly take. We need not check whether they are computed or not. So it would be I j minus 1 plus dp of I minus 1 j. Okay. Now at the end of it, dp of m minus 1 n minus 1, which is 2, 2 comma 2 in this case, will have the answer. We just return that. Okay. Let's run this and see. Okay, let's submit this. Now here time complexity is order of n square and space complexity is also order of n square because we are initializing a DPR. Okay, so here we saw that this can be solved by the sub problems, and in the sub problems there were many overlapping ones, and we saw that we can easily approach this by a tabular DP approach. Okay, hope you enjoyed this. In this particular problem, the idea is the most important one. Visualizing it and coming up with this idea is more important. The actual solution is pretty simple. Hope you liked it. Thanks for watching.